So really the focus of the session today is just working as an Agile developer. You see a lot of, like if you were to Google Agile developer, it would actually give you a ton of hits, and none of them would really apply to the craft of software development. It's really about in terms of technologies and practices versus implementing technical as a mindset or way of life for a developer. So, but it's kind of important because what we're finding out is if you look at things like organizational level for methodologies, really a mindset around Agile starts from the developer up. It doesn't really, the organization may want to develop their software or run their projects in an Agile manner. But if the individual developers, the engineers aren't working in an Agile manner, if the teams are not collaborating as Agilists, then really it's just simply another methodology for managing software that may or may not be successful, and whose outcome is predicated that in addition to certain ceremonies in an Agile world, certain development practices are undertaken, all right? So really tonight's lesson is not just about, you know, developing as an Agile developer. If your organization isn't Agile, it can be Agile. If the mindset for Agile isn't with the developers and the engineers on the team, it's still not really a great Agile experience. And that's kind of the heart and the soul of it, of what I wanted to get to, because there are certain things that developers should just pick up as part of their tool set, as part of their mindset in their day-to-day work, whether their organization works this way or not. It just makes their practice of developing software stronger. And that's really what I wanted to hit on. Just some certain things that, and it's not a lot, it's not a ton, but there's just some few crucial things that if they certainly implement as a code, as a way of life in terms of their development and tooling and the way they approach coding, it takes them to another level of engineer, another level of developer. And it's really kind of the whole crux of the talk and why I thought it was important. So at the organizational level, you may have different methodologies. Organizations may want to do waterfall, they may want to do Agile, they may want to do waterfall, which is an aggregation of both. And I think most companies, we could say, really do a lot of hybrid of waterfall, Agile, kind of waterfall. And they call it Agile, but it's not really. But regardless of the methodology, it's not really a top-down approach. It is in terms of the PMO, maybe. Maybe the PMO is strong. It wants to do Agile development. Maybe you have good Scrum Masters. But Scrum Masters don't write code. They don't do CI/CD pipelines. They don't implement a lot of the practices around Agile. That Agile really is aimed less actually as a methodology and more as a lifestyle for developers. If you really read the Agile Manifesto, you'll see that. We'll cover some of that tonight. But I think it's important. A lot of us think that the Agile Manifesto is for the Scrum Masters and the PMO and the Scrum types and all that, but actually the Agile Manifesto was written by software engineers. It wasn't written by PMO. It's just been co-opted as a development methodology and built upon. There's actually Dave Thomas, which is one of the founders of the Agile methodologies and the Manifesto, has a whole YouTube presentation called Agile is Dead. And it's really not even, it's kind of clickbait because he's actually not saying Agile is dead. What he is saying is that Agile has been co-opted by companies who want to sell classes and tooling to make you Agile and all these other things, where really the intent of the Agile Manifesto was to encourage Agile software development practices, not management practices. So Agile really starts at the individual level, but the next level up is the team. And of course, next to that is the individual. So tonight is going to be really focused, it's not really focusing on the organization, although the benefits of Agile come from the bottom up. But it really starts at the developer level and then flows into the team level. The team can survive without the organization implementing Agile methodologies. And you ask, why, how is that so? Well, it actually is fairly simple, because there's a difference between planning a project and implementing software, right? I mean, it's clearly, right? So and that is, we can plan things all day, whether you're waterfall, whether you're Agile, you can do nice backlog. If the development team isn't rocking an Agile mentality and an Agile mindset, then it's really just going through the motions without much benefit. So there's a very big difference, a very dichotomy between planning a project and the implementation of the project. And once we understand that, it's easier to get into more of an Agile mindset. Even if your company does Agile, it's easier to get into that mindset and get your teams into this mindset by implementing some very simple things. So let's dig in a little bit. So if we look at, we're going to actually consider a lot of the manifesto for Agile software development. It's been, a lot of us refer to as the Agile Manifesto, but to be very clear, it's the Manifesto for Agile software development. So if we look at just some of the basic tenets, like the highest priority is to satisfy the customer through early and continuous delivery of valuable software. Welcome changing requirements, even late in development. Agile process harnesses change for the customer's competitive advantage. Deliver working software frequently, from a couple of weeks to a couple of months, with a preference to shorter time scale. Business people and developers must work together daily for the project. Build projects around motivated individuals. Give them the environment and support they need, and trust to get the job done. The most efficient and effective method of conveying information to and within a development team is face-to-face conversation. Working software is a primary measure of progress. Agile processes promote sustainable development. The sponsors, developers, and users should be able to maintain a constant pace indefinitely. Continuous attention to technical excellence and good design enhances agility. Simplicity, the art of maximizing the amount of work not done, is essential. The best architectures, requirements, and designs emerge from self-organizing teams. At regular intervals, the team reflects on how to become more effective, then tunes and adjusts its behavior accordingly. So I really challenge you to find anywhere in there that speaks of Agile as a development lifecycle, as a methodology. It's really about how we write code, how we develop software, and how we maintain and deploy software. Really at the heart and soul of it. So this lesson is really just about getting back to some basic fundamentals in terms of what Agile really means and how engineers can embrace that and use that to take themselves to the next level. So if we take everything we just read and we boil it down to just a few things, just a few line items to make it easier to understand, we can boil it down to four basic concepts. Individuals and interactions over processes and tools. Working software over comprehensive documentation. That's an interesting line there. Working software over comprehensive documentation. You know, a system is not well designed and has lots of defects when there's a lot of copious documentation on how it works. Like, you click this button twice and then hit the up key and then scroll over here in order to get this thing to work, right? So that's not well designed, but you need documentation to understand it. So again, one of the aspects of Agile software is working software over comprehensive documentation. Customer collaboration over contract negotiation. In other words, the customer is actually part of your development process. You don't you don't spend a year on project plans and kickoff meetings, go away with your team for 6 months and come back with a product. The business is constantly engaged on how work is done in an agile manner. Now, that may or may not be within your purview to do as an engineer, as a developer, but certainly finding time to interact with end users and stakeholders will help your process. And again, there's some other things that developers and engineers can do to kind of settle this, involve this, or have this collaboration without actually like formalizing it into meetings and structures. The other thing is responding to a change over following a plan. And this is kind of one of the fallacies of, not really fallacies, I would say weaknesses of waterfalling, that there's so much effort put into gathering so much detail that may change over time. You see this on long projects when it takes 6 months to a year to actually build something, and it's not done iteratively. Perhaps the project is meet a very specific market need, and that market need changes in the course of development. So now requirements change, and everything has to be thrown out and reworked. Right? You see this continually. So again, one of the core principles is responding to change over following a plan. And if we take those 12 things we talked about and really just boil them down, in a nutshell, customer satisfaction is the top priority. Embrace logical change at every step of the project. Create working deliverables and then gradually improve them. Business and technology people need to work together. Build projects around motivated teams to produce quality results. Face-to-face communication is preferred over other forms of interaction. A little bit difficult to do in the way we used to pre-COVID, but certainly, during COVID, and reality is after COVID, most businesses have transformed their landscape to be not in office or to be fully remote or hybrid. So, face-to-face communication is really going to be about Zoom meetings or team meetings or whatever. But still, that's preferred over just simply, especially in terms of really good collaboration, software design, working through issues, much better than any other form of communication. A working product is the best measure of success. And if you really stop and think about that, that should be paramount in whatever we do, right? So our jobs are to build, working products that fulfill client needs. If we don't deliver them, we haven't been successful in our implementation. Aim for a sustainable pace of development. Invest sufficient time to produce quality products. There's power in simplicity. Don't over-design it. Don't overthink it. Self-organizing teams are ideal, and you can learn valuable lessons from both failure and success. So how do these really apply to an engineer or a developer? Let's just break them down. Take a few principles. These are principles that we can keep in our tool chests and incorporate in our daily activities that should help us and our teams be more successful at delivering good software. So principle number one, prepare for change. The only constant is what? Change, all right? So how do we prepare for change? Well, the principles that we're aligning our work to come from the manifesto. Welcome changing requirements, even late in development. Agile processes harness change for the customer's competitive advantage. Embrace logical change in every step of the project. So how do we do that? Very, very simple, right? There's some very simple things we can do to prepare for change. Number one, writing tests. I saw the lecture by Dave Thomas, and interestingly enough, he said that because he has done so much system design, and tests are really about understanding and measuring the integration of code and methods within code and making sure the inputs and outputs are good, that he rarely writes tests anymore because he's done this so much that he himself understands the system design and understands the input and outputs. I would counter that the reality is there's no one single person here that's going to be working on one software system for the entirety of their career. So as a result, we write tests because we know that other people will have to understand what the code does and understand input and output. And this is how, as we maintain and tweak the software over time, we understand the health of the software, right? So, and as we make changes and we implement new features or adjust to defects, these changes that we make may impact the system at large. The unit test a granular part of the system, and the integration tests really test how everything fits together. So we do this up front. We do this up front preparing for change. We do this up front because we know that as requirements change and features change, we'll have to change code. And those changes may introduce breaking changes that we may or may not be aware of, depending on the system that we're in. So we prefer to get ahead of this up front by writing the unit tests and the integration tests, because we know the change inevitably will occur. Even if it doesn't occur in this phase, it will occur in another phase of the project. So therefore, get in front of it as an Agile developer, write good tests, because tests are key to understanding change and measuring code quality and making sure that what we're delivering works as designed, right? The other thing that I see that we tend to do a lot of, especially in POC work, is we seem to do a lot of hard coding when it, just to get something done, when it really does not necessarily have to be so, right? Because we can prefer configuration, especially in today's world in software. And again, it goes back to the concept of preparing for change. My code is not going to run forever on my box. It's not. It's going to be pushed to other environments eventually. So that's one part of change. The other part of change is as we get new requirements, as I roll off the project and roll on something else, and somebody else rolls onto the project, they're going to have to make changes. As we deploy system to system, which goes along to continuous delivery, the environments in which we're delivering in have different configurations. Knowing this ahead of time, we should prepare for that, prefer configuration, or at least environment variables, anything that's flexible, prefer configuration over other methods of putting those things in. And we have a little code example here of a database config in which we're injecting, perhaps at runtime or compile time, depends on how it's implemented, maybe that username and that password for the database. We do this from using secrets tooling, right? So this is another tool set that most Agile developers have, is the ability to understand how secrets work and to inject those secrets at runtime or compile time as part of the configuration to make it more dynamic and flexible, because we know it's not going to stay the same, right? Database names change, usernames, authentication changes, environment variables change based on where we're running code and executing code. Prepare for that, understand that, and early on build in your configuration. Prepare for that, and prepare for using some type of tooling or secrets that will let us hide the sensitive information and protect the clients, right? So very simple things we can do to implement that one value from the Agile Manifesto. Be prepared for change. What's next? Well, let me see. Develop iteratively. So this is actually, you can almost do an entire presentation on developing iteratively, because there's a lot of aspects to it. But in a nutshell, and to make it pretty easy, our highest priority, again, coming from the Agile Manifesto, quoting its values, our highest priority is to satisfy the customer through early and continuous delivery of valuable software. Deliver working software frequently, from a couple of weeks to a couple of months, with a preference to a shorter timescale. Create working deliverables, then gradually improve them. That's the nutshell of all those things. So how do we do that? Well, developing iterative means that we're going to develop some strategies around early coding when resources may not be available. You know what I'm talking about. You need to mock up an API because you need to get started. You want to get started to work on the API, but you're not really sure what all the data contract looks for the API. You might not have the Swagger doc. You might not have the spec sheet. You might not have the model that's going to be pulling the data out of the database and sending it to your API. You may not have these things. Is that going to stop you from work? Is that a blocker? No, not to an Agile developer, right? Because we have other tooling and other things that we can implement in order to overcome this roadblock, right? So we have a ton of mocking tools. There's a very mature mocking system, mocking services out there that we can use to mock up data contracts for APIs. Today, do I really need to know everything? Do I need to know the nuances around data? No, I just need to know that, have some basic idea that I have some columns, I have some fields in my data contract that's coming in to my API, whether it's a REST API, a programmatic API, whatever, and that once I get that data, I need to do certain business process with it. There's nothing that's going to stop me from at least using mocking tools to mock up a data contract and building a REST API around that mock data, knowing that I'm going to have to tweak changes to the data contracts once it's ready. That is by no means as a blocker, right? So it's really getting to that mindset, a very agile mindset, and having a really broader worldview where you're not stuck in the minutia of things. And I see engineers actually really struggle with this a lot. A lot of them get stuck in how can I actually build this if I don't know the data that's coming in, if I don't know the outputs that are coming out. And the reality is, you know what you need to know. You have data coming in and you have data coming out, right? What that data looks like, yes, you'll have to deal with that at a certain point. But to get started, again, what are we looking at? Getting something out early and fast, getting ahead of the game in terms of development. And so the Agile developer thinks about this. He overcomes those obstacles by implementing tools. I mean, you can mock a data store. You can build by hand data models in hours that you can then use to build out the rest of your API or the functionality of the things that you want, right? So it's getting into this iterative mindset where I can create something initially, then I can iterate that over the next course of the next sprint or 2 sprints until it's solidified. But we do this and we do this often. I think most of us that have done REST API work, how many of us have actually started a project where we had the full Swagger docs or the full specs on the data coming in? Like very few of us out of the gate have that. Some do, sometimes we're lucky we do. How many of us have actually had the data models that the data is going to? Like probably very few of us, right? So we can implement tooling, we can build these processes so that we can get a jump start and develop iteratively, because that's what, again, following Agile development. Regardless of if I'm following waterfall or not, I still need to build this. And I still need to understand the data coming in and out. That's not a blocker for me. I shouldn't be waiting for the data team to get me models or for someone to generate me a Swagger doc. If I'm dependent on other resources, other folks to do this, I can overcome that by implementing nice tooling, or I can hand build JSON packages if I need to get my code working and underway. All right. So it's really about overcoming obstacles, thinking more agile. And if any time you have questions, please don't hesitate to ask. Right? So the next one is kind of tied into this. A lot of these dovetail together, right? So as an Agile developer, I want to think critically. And of course, you're like Kevin, I'm an engineer. I think critically all the time. Well, I'm sure you do. But when we think critically, we're really tying it back to very specific skill sets, right? So I tried to design the deck here in a way that for every principle, it's pointing back to the source principles and values found in the Agile Manifesto so that you can contemplate them and think about them. And think about how you work, right? So value, welcome changing requirements. Again, you're going to see this a lot, right? Because this is a big problem in a lot of projects, continually changing projects. Even in Agile projects, it becomes very chaotic to work with continually changing requirements, right? But at least Agile provides some thoughts around how to manage that, right? So welcome changing requirements. Even late in development, Agile processes harness change for the customer's competitive advantage. We see that repeatedly. A lot of things tie back to that. Continuous attention to technical excellence and good design enhances agility, and that's kind of key, right? Continuous attention to technical excellence and good design enhances agility. It's quite the opposite of what we see a lot with the get her done attitude, right? Sometimes we just got to get her done. Well, the reality is Agile developer is thinking about ways to get it done, but get it done in a continuous attention to technical excellence. And sometimes, you know, there is simply a get it to possible. And how do we do this? So the Agile mindset is geared towards creating teams, a workforce, and it can adapt to change as it comes along. This starts with you, the individual developer, right? So you have to be able to be a problem solver. Have to be able to be adaptive. A lot of things come unforeseen at times. I think a lot of this I see in terms around like, what are constant unforeseen issues we face as engineers? Well, we develop an API, and when it's in development and UAT, it's very performant. And now that we're in production, not so much, right? So it doesn't scale well. There's a lot of latency. These are things that we think about. So being able to think out of the box and critically ascertain and understand processes, digging through logs, understanding metrics, measuring throughput, using performance tools, all those help us get to a place where we're able to understand what's going on. But also knowing probably that you need these tools early on is another aspect of thinking critically, right? While wait for a problem to arise. All of us know that at scale, things slow down. So get in front of your work by introducing these technologies ahead of time so that you'll have an idea of what performance looks like prior to going to production. Use load testing, use performance testing ahead of time. And when you have problems, try to think out of the box and solve it, right? Think objectively. Identify the problems and how they relate to situation and people. Sometimes, users will say, hey, this is, and under this scenario, everything, we might fail because it's too much. But then you have to really identify, are we ever actually going to hit that scenario, right? You can get lost in rabbit holes. So sometimes critical thinking helps that, right? Evaluating different points of view, like there's no one single view. Sometimes a different perspective or a different way of looking at things helps you actually maybe, if not identify the problem, certainly fix the problem. So again, collaborate with your teammates, get certain points of views, think critically, get in front of things, try to work on iterative solutions. I see this a lot, like problem, work on it iteratively until you actually fix the underlying problem. We all know how technology can be. It can be rabbit holes. So being able to iteratively work through solutions is good. But iterative is also an agile concept, right? Doing things incrementally. Next item is collaborate. And this is hard to do and well, I should say harder to do, maybe a little bit more challenging to do, doing remote work in the COVID days. But obviously a lot of companies do it and a lot of companies are successful doing it. Terazo used to be a company that really wanted folks to be in office. But, the pandemic came and pushed us all remotely. Now we're at the point where we're not going to require any engineers to be in office. It's going to be optional because we found ways to collaborate. So again, an agile developer, both individually and as a member of a team, finds ways to collaborate, right? We have one group of folks, interesting group of engineers. They call themselves the Goon Squad. They're self-named. It's like no one gave them this name. They decided to name themselves this. And part of the Goon Squad's routines is when they're in spikes or in like all hands on deck, we're trying to figure out the solution to this thing. They get on Zoom and they spend the entire day on Zoom. Now, that might sound crazy to you. If they don't have meetings, what they do is they open up a Zoom channel. The entire team works together. They might not say a word for 2 hours, but they're just all there working as a team together, working on the project or on their pieces of a project. And they may banter, They may actually eat lunch together. It does a couple things for them. Number one, it makes them very collaborative. It also makes them very close as both engineers and as friends. They've become actually social circles outside of work form around this. And they form a circle of trust that is fantastic to see. And we'll dive into it in a minute when we talk about self-organizing teams. But, you know, it's also, they realize that very important part that the Agile Manifesto sets, and that is face-to-face communication is preferable, right? I mean, we can Slack, and Slack is good for some things, but in terms of really working through software design, engineering concepts, working through problems collaboratively, just working on implementing certain feature sets, there's no real replacement for doing it face-to-face on a Zoom call or something, right? So the most efficient and effective way is face-to-face communication. The best architectures, requirements, designs emerge from self-organizing teams. So face-to-face is preferred, self-organizing teams are ideal. All right, so peer-to-peer collaboration is key, team collaboration is key. It's not to say that developers and engineers don't go, and I use them interchangeably, you know, don't go away and work on their own. Of course, they may spend the vast majority of their time working solo, but they know when to peer program, they know when to peer review, they know when to have a conversation about a solution, or they know when to say, I'm struggling with this particular thing. I don't really understand why this container isn't working. Can someone give me a hand, right? So it's about understanding that peer-to-peer collaboration makes for a stronger experience developing. It makes for a stronger team approach. And invariably, you know what? It makes you a better engineer. Why? Because you're learning from someone else. Those shared experiences, you know, get internalized and are available for other people if they ever run into that problem, right? So collaboration is key. Just an effective team can get more done than even an effective individual. I strongly advise solutioning as a team, right? What does that mean? If you're going to enter your sprint, or even if you're not doing sprints, if you're just doing your day-to-day work, you know, solution as a team. Figure out, figure out holistic design as a team. Make it a team approach to solution, so that kind of everybody has an idea of the pieces and parts, even if you're developing different ones of it, because as you run into roadblocks, as you run into things that you haven't thought through, your teammates will help you through that. So that's very important. And it also learn from people, like maybe Sujit is actually better at solutioning portions of the project, or even holistically. Maybe there's a solution I've never done before, so I can learn from him. It enhances my skill sets, right? So that also ties into the next bullet point, which is defer to team members that have specific strengths, right? So when you solution as a team, you get a chance to do that. You learn from each other. And finally, the definition of self-organizing team. It means different things to different people, but in a nutshell, a self-organizing team is one that really doesn't wait to be assigned work. It kind of looks at what needs to be done, whether it's the project plan, whether it's the backlog, and they kind of organize themselves and manage their own work. They themselves adopt the workload. They work internally on their work, and they really don't need to be managed to that degree, right? So they just don't sit around, well, we have project kickoff, but the manager hasn't actually assigned the work. They proactively look for things to do. They proactively find the backlog items. They look on the project plan and find out what tasks are getting assigned to them. And they go ahead and either take those tasks. Most Agile developers prefer backlog. I've even seen project plans that get translated into backlog items, so that then it's a little bit easier to manage kind of where that work is in progress. And a lot of engineers will do that kind of on their own, just because it helps them track their work and mitigate risk, look at dependencies and all those kinds of things. So self-organizing team can be very effective, especially if you think of a team that's working on a particular feature and they're blocked on something. I've seen really some teams do some amazing diagnostics and overcoming things within a very short amount of time, just by being collaborative and being together on work. So self-organizing teams. Goes back to that principle of collaboration. Another principle, key principle, deliver early and often, right? I try to, again, tie everything back to the manifesto. So our highest priority is to satisfy the customer through early and continuous delivery of valuable software. Create working deliverables, then gradually improve them. All right, so this includes thinking about some of those iterative processes we talked about earlier, right? So deliver early. I shouldn't have to wait for people to get me data contracts, models, or other things to begin to work, right? If that were the case on some projects, I would probably sit around for 2 weeks and not have anything to do, right? So it's really about getting in front of the work and using those mocking tools, but getting that I'm going to iterate through that process to get it where it needs to be. But I can go ahead and start working on that process. I want to deliver something early. I want to have something done within, a 1 week or 2 week period. I want to have something to show for that. Get my environmental setups done and out of the way if I can, right? Set up and build processes, pipelines, do it early. If you are, if you work through an iterative process, if you've done what you can do and you're kind of at a point where you're waiting, go ahead and get your build process set up. Go ahead and get your delivery pipelines, right? That's something you're going to need anyway. Why wait till later, right? The earlier you get that, at Terazo, we really found that getting this out in front of these delivery pipelines and getting our environment set up as early as possible, even pre-coding, helps a lot. And I think Sujith and Luke and some of the other folks I see on here will probably agree, right? Because the faster I get my foundation for good delivery in place, the better experience in terms of quick turnaround on code and deliverables is going to be. Again, these are things that are not tied to any methodology for managing your project that have to do really with how you work more effectively as an engineer, right? So get in front of things, get your pipelines done. If you don't do pipelines, figure out your build processes. Everybody has the build code, right? So get it working locally, figure out your dev environments, your whatever environment you have, get your build process in place, get it done early. The quicker you get it done, the faster and better your experience is going to be on delivering the project, right? Because even if the team is coming in late, because we can't pretend like that never happens, even if they're coming in late, having that stuff in place and working just still gives you an emotional lift and an intellectual lift, because you still know that you might be late on delivery, but the metric there to see how fast you can get done is there. And that's really a lot of times what you need, right? And a lot of times at Terazo, we try to parallel this work, right? So we're doing environmental work and build setup and pipelines along while we're starting development. Just seems to really expedite things and make things better. And dovetailing into that, establish your CI/CD pipeline. So go for continuous integration, go for continuous deployment. I've seen a lot of companies that waterfall their methodologies, they hand over a project plan, and the engineers take that project plan, they then generate backlog items, and they always start implementing good tooling and processes, right? So even if my methodology for the project is waterfall, I can still adapt the concept of every time I check in code, I need it to build. And I need to check the quality of the code. So I need that continuous integration checks. And I can probably push constantly to my dev environment and then set up schedules for other things, right? I can set up deployment schedules to stable environments. Maybe I push to my dev environment hourly or upon integration. Maybe I push to my UAT environment, my staging environment weekly. And a couple of things that does, right? You can always inform your stakeholders, hey, did you want to check out what we're working on? If you do, hey, here's this URL, check it out. You can see kind of where we're at. So even if your planning phases are waterfall, your delivery does not necessarily have to be. So remember what I said early on. There's a big difference between planning a project and implementing a project. And they're not necessarily tied together. All right, so we're kind of winding down on things. So let's talk about refactoring, code reviews, and PRs, because this is very specific things that teams do. And we want to talk about the agile principles that they are referring to, right? So when I think of refactoring, code reviews, and pull requests, I think of continuous attention. Again, say a lot of these are redundant, right? Continuous attention to technical excellence and good design enhances agility. Deliver working software frequently, from a couple of weeks to a couple of months, with a preference to a shorter time scale. Working software is a primary measure of progress. So, question, what does refactoring have to do with being an agile developer? Well, it goes back to improving the internal structure or operation of a code or component without changing its external behavior. It makes the code more maintainable over time, more flexible, and more easy and easier to test. Right. So again, if I think of planning for change, I know that changes are going to come with the code base, maybe even before we go to production. Certainly, as the business gets the software, they find defects, or they're found, or they need new features, and we're going to be making changes. Then refactoring code to a better state just makes it more maintainable, and it does a couple things. The code's more maintainable because smaller units that do less work. So understanding what each unit of work is doing is easier when I look at the code, and being able to build tests around that is much easier. If I have huge methods that do a lot of things, I can write a test, but is it really fair when I have 6 different operations within that method? I should really have 6 different methods if that's the case. Each method should have a very utilitarian process and do one thing and one thing only, right? So it makes it easier to test, which means that refactoring actually helps me prepare for change and plan for change. And also, remember that good software, working software, ties into that, and also the design concept, right? Always striving for technical excellence and good design. So that's what refactoring does, and that's how it ties into it. One of the side notes I have here is, go for better ways of writing code. Go for more IOC. Go for more inversion of control, dependency injection. Go less for concrete implementation. All of us have a tendency to go for concrete implementation to save time, but does it really save a lot of time? I would argue that once you get really good at IOC and DI, it doesn't save much time. Like you kind of get it out of the box, and a lot of the tools kind of make it easy to work with. So just think about that. Think about that. Makes your code much more flexible, less brittle, which also ties into better quality code, higher technical specs, and preparing for change, right? Next question is code reviews and agile principle. Answer is no. Code reviews should be done regardless of whether you're doing agile or not. Code reviews have been around for a long time. But what it does is it does push individuals and teams toward collaboration, technical excellence, and good design. Why? You have your peers looking at code. Sujith is coming back and saying, Kevin, why would you ever write your code like this? Like, you should never do that. Look, the way you wrote this object might never ever be created, and yet you're using that object later on in code. It's bad design, right? So having a second set of eyes is really good on your code. It should be part of how you work as a team. It fosters collaboration. It fosters learning. And again, it ties back to everything we talked about: good design, collaboration, delivering good software. And PRs is something I get asked about a lot, because a lot of people think that and approach the PRs, and if you Google search PRs in terms of like a repository, it'll always say this is a feature of GitHub. Well, it's not necessarily just a feature of GitHub. A lot of source control software these days have the concept of pull requests. So what is a pull request? It's a feature of source control that allows developers to review changes made to code in a branch, and that can either reject or approve those changes prior to all those changes being committed to your master branch. So why is this good? Well, might stop you from introducing crappy code into your pipeline, to your master branch. It certainly provides good peer feedback and visibility, transparency into what's going on with the code before you deliver it. And you learn from PRs too, right? Because when Sue just gets done reviewing my PR, or Luke gets done reviewing my PR, then I probably have learned, you know, maybe it comes back and you're like, it's all good. Maybe they come back and say, we have a few suggestions that you might want to consider making before we actually commit to this. And I learn from that. It usually makes me a better engineer and increases my ability to design and deliver better quality code. All of this ties back to delivering good software, better work as a developer, right? And really PR should just be a best practice in general. You don't need a tool that, it's a practice, right? So you don't need a tool that really enforces it. You as an individual developer, you know, as you commit changes to your branch, you can review code and you can invite somebody to review your code. You don't need a tool to enforce this. You can make this the best practice, right? And you'll find that as an engineer, when I have this in mind that I need to get people to review my code, it just makes you a better developer on the onset. And certainly making it a team best practice just makes the team better. Now, just kind of wrapping up everything, and then I can have a few minutes of questions before I get off. But just some key benefits, because I know we talked about benefits to individuals and teams, like how does this really make me a better engineer? Well, in a couple ways. Even though we're engineers, we're still leaders and we do some level of management, whether we're managing ourselves or we have responsibilities managing teams, or we're trying to coach more junior engineers, or whatever it may be. You know, the Agile mindset, because it takes me to another level of how I think and how I work. If I can push this in terms of thought leadership and management structures to other folks around me, it helps me and them, right? It promotes that leadership and empowers individuals, because it allows me to take more control of how I work and how I deliver my code versus waiting for other people. It encourages self-organizing teams, and that in turn usually generates better code quality. It certainly improves knowledge sharing, right? Because as a team, we're learning from each other. It places more emphasis on face-to-face communication, interactions. The more face-to-face I have with my peers, the closer I feel to them, the more I trust them, and we just seem to gel better and work together as a team. And it also makes everything much more transparent, which is a part of Agile, right? It's transparency to the things that we do and how things work. Gets rid of the whole black box concept all the time, right? Black boxes we find in technology are not really good. Sometimes they are for the end user, not necessarily for the development team there, right? Faster problem solving. Why? Because I have a team of folks. I can individually look at it, think out of the box, find ways to iteratively solve it. If I can't, I have a team that can support me. We can then, you know, get together and work as a team to problem solve. Right? I have faster work output because I'm working on not just trying to get through a particular feature set. I'm working on delivering a certain deliverable, which is probably a subset of that, making it sure it's the best it can be before I deliver it. It helps me just collaborate and innovate on things to do. And I love how teams work together, right? Because we're always looking for cool tools and better ways to work. And everybody, you always have that one guy, two folks on their team that always are into tools, right? And they're always saying, hey, have you heard of this new mocking thing? Have you heard of this new thing that does this? So having that kind of innovation also helps too, right? Work smarter, not harder, kind of that concept, right? We also have an appreciation for customer values, for what the, you know, building software that the customer truly wants. And even if it's like, okay, you guys go away and come back in 6 months with the software, you know, if we adopt an Agile mindset and apply it, and we can also let the customers enjoy some of the work we're doing by having those, you know, every 2 weeks or every month look at the software and kind of where it's going. So they get even some of the benefits of agile development, even if the project isn't being delivered holistically in an agile way. And incorporates good tech tools and human intelligence for optimum performance. So in summary, achieving an agile mindset is a process. It's not something that happens out of the box. You learn it over time. The more you work, the better you get at it. Takes a lot of individual effort. So the cornerstone of agile work is the individual. And as individuals, we improve our mindset around agile processes, and not only the processes, but how we work, the way that we write code, the way that we deploy code, the way we design code. All of this takes time, and it's a lot of individual work, but the strong individuals make up strong teams, you know what I mean? So, and that strong team really just helps deliver good software, right? It's it calls for participation process. It's not going away and locking yourself in a closet and working. It calls for a more proactive approach to how you write code and how you interact with your teammates and constituents and other peers. As each team member gets stronger, the team becomes stronger, so they become more efficient as they work together. It's kind of a growth mindset in terms of, you know, you're sharing common goals, but you each are individually working on those goals as individuals. So you're individually working on goals to get better, and collectively as a team, you kind of have that same subset of goals, and everybody's working on it. Again, kind of just the challenges are embraced, resolved more quickly, obstacles are dealt with. And every step feeds on the next step. The success of others is celebrated as the team gets their deliverables out and then starts incrementally building on those. So it's just like a constant improvement. So I hope everybody enjoyed that. I'm a tad bit over. I can probably carve out maybe a couple minutes for question and answers though, if anybody has any.